Hello everyone, my name is Gulbarshin Mukasheva, PhD, Senior Lecturer of the Department Epidemiology and Biostatistics. Today I am going to present a lecture on the topic Parametric and non-parametric tests for analyzing quantitative variables. Why is this topic interesting? You want to perform a hypothesis test, but you are not exactly sure about the difference between parametric and non-parametric criteria and when to apply each. If you want to calculate a hypothesis test, the first thing you need to do is check assumptions. One of the most common assumptions is that the data should follow a specific distribution, usually a normal distribution. In this slide you can see types of quantitative variables, continuous and discrete. Here shown examples. Continuous numbers is fraction numbers, discrete is whole numbers. Here you can see examples for continuous variables: height, body weight, blood pressure. For discrete, number of children in the family. If the data follows a normal distribution, parametric tests are used. For example, t-test, ANOVA, Pearson correlation. If one of the data sets is not normally distributed, non-parametric tests are used. Mann-Whitney test, Spearman correlation, for example. Types of hypotheses. There are two types of hypothesis: null hypothesis. This is the primary initial hypothesis. It suggests that there is no change, difference, or relationship in the study. For example, the mean values of the two groups are the same. Alternative hypothesis. This is the opposite of the null hypothesis. It states that there is a difference or relationship in the phenomenon being studied. For example, the mean values of the two groups are different. Significance level. The acceptable probability of making an error when making statistical decisions. It's typically denoted by alpha or p. A common value for A is 0.05, meaning the researcher may make a wrong decision with a probability of 5%. Types of errors: alpha error, type 1 error. This occurs when the null hypothesis is true, but we incorrectly reject it and accept the alternative hypothesis. For example, there is no actual difference, but the study results indicate that there is one. Beta error, type 2 error. This occurs when the null hypothesis is false, but we incorrectly fail to reject it. In other words, there is a real difference, but the study fails to detect it. First of all, we should check data for normal distribution, so we should know conditions for normal distribution. The mean and median should be equal, skewness should be between 0 and 1, the histogram should be bell-shaped. In a QQ plot, the points should be lie along the line. Then here, algorithm of parametric and non-parametric tests. First of all, we will ask question: are data normally distributed? If yes, we will use parametric tests, and if no, we will use non-parametric tests. Then types of groups here shown. There are three types of groups: independent, dependent, and related to set point. Independent means there are two independent groups, for example, boys and girls. Dependent groups, we can understand this by before and after results. There is one group only. We will compare the students' group results before lecture and after lecture, their MCQ marks. And related to the set point, it means we'll compare our results with normal or with another research results. Here we will have only one group. It means our only research results. And independent groups divided into two group and more than two group. If we will compare two independent groups, we will use t-test for independent samples. If we will compare 3 and more groups, then we will use one-way ANOVA test. For dependent groups, also used another tests. If two dependent groups we will compare, then we will use paired sample t-test. If we will compare 3 and more groups, then we will use PM one-way ANOVA test. And for only one group, we will use one sample t-test. And next, we can notice group names same and group numbers also same, but test names only different. We should learn this each type of tests. For independent two groups, used Mann-Whitney test. For independent 3 and more groups, Kraskal-Wallis test. And for dependent two groups, we will use Wilcoxon sign and rank test. For dependent 3 and more groups, Friedman test. And for related to set point 1 group, Wilcoxon sign and rank test. Parametric test, students t-test. Independent samples t-test, comparing the means of two independent groups, for example, determining the difference in average height between male and female students. Next type, paired samples t-test, comparing two related measurements taken from the same objects. For example, the change in stress levels before and after meditation. Third, one sample t-test, comparing the mean of the one group with a theoretical value. For example, testing whether the average sleep duration of students is different from 8 hours. Parametric tests ANOVA. One-way ANOVA used to compare the means of 3 or more independent groups, for example, determining whether the type of diet, vegetarian, keto, standard, affects blood sugar levels. Repeated measurement analysis of variance used to compare 3 or more measurements on the same object, for example, measuring blood pressure of patients in the morning, afternoon, and evening. Non-parametric methods. Mann-Whitney U-test, comparing two independent groups when the data is not normally distributed. For example, you want to compare the level of satisfaction with service in two different hospital departments. Satisfaction levels are measured using a rating scale, so the Mann-Whitney U-test is used. Kraskal-Wallis test, comparing more than two independent groups when the data is not normally distributed. For example, you want to compare the level of satisfaction with service in 3 different hospital departments. Here we will use Kraskal-Wallis test. Next, non-parametric test, Wilcoxon test, compares two related groups with not normally distributed data, for example, comparing pain levels before and after therapy. Friedman test, comparing 3 or more related measurements, for example, assessing students' language proficiency after 1 month, 3 months, and 6 months. One sample Wilcoxon test compares a single sample to a specific value, for example, testing whether the average weight of 70 kg is different from the normal value. Thank you for your attention.